Good day, everyone. So, our topic for this session is about ether. I am Dr. Erwin R. Aprensive. So, for our learning outcomes, which will serve as your guide for today's topic, these are describe the properties of ethers and epoxides, determine the steps in writing a correct chemical name and formula of ethers and epoxides, and name and create chemical structures of ethers and epoxides. So, the functional group of an ether is an oxygen atom bonded to two carbon atoms. As you can see on the illustration, you have here the oxygen atom. The valence electrons of oxygen atom is equal to 6. So then therefore, the two of those valence electrons are bonded with carbon atoms. On the right side of the image is the ball and stick model of ether. So the one on the left and the one on the right are the same. They are just different in terms of the presentation. So the one on the right is a ball and stick model. So let us now proceed to nomenclature or naming of ethers and epoxides. So for a UPAC system, the longest carbon chain is the parent alkane. So as I've said before in my previous video, that majority of the functional group will follow the same format in naming, and that is the selection of the longest carbon chain. Then name the OR group as alkoxy substituent. So the OR group is the one with the carbon bonded with an oxygen atom. They will serve as alkoxy substituent. So alkoxy, in doing that, these are some of the patterns. So methane or methyl will become methoxy, ethyl or ethane, two carbon bonded with oxygen, that will become ethoxy, then propoxy, butoxy, pentoxy, and so on and so forth. So there's also the common name. Name the groups bonded to oxygen, followed by the word ether. So in terms of the common names, what you can observe here is that the last letter or the last word in the name is ether. So anytime that you will encounter such, so that means that is a common name of that particular ether. So for example, we have here ethoxyethane. So ethoxy because there are two carbon bonded to oxygen, and ethane because there are two carbon also. So in this example, on the other side, here on the second example, you have here 2-methoxy 2-methyl propane. So this is a UPAC system. Let us look into this. So why is it 2-methoxy? Again, you have to locate the longest chain of carbon. And in this example, I have here my highlighter. So this is your longest chain. Okay, so 3 carbon continuous chain. So that is the propane group. Okay, and then you can label it since they are of equal side, whether you start with the here on top or here at the bottom, the OR will receive the same number, which is 2. So let's say, for example, you have here 1, 2, and 3. Then that's why you have here 2-methoxy. So this is the methoxy group. So that's the OR. And then you also have here the metal substituent, which is 2-methyl. In this particular example, you have to start first with the alkoxy group. So in this case, you have there the 2-methoxy, and then followed by the other substituent. In this case, it is methyl. So that's why it is 2-methoxy, 2-methyl propane. Okay. So propane because there are three carbon chain. So we have here another example, 2-methoxypentane. So again, you have to locate first the longest chain possible. So in this case, you have here this vertical, a horizontal line, and then you have to select the closest alkoxy. It is closer to the left. So this is the alkoxy group. So this is methoxy because there's one carbon here. So label it 1, 2, 3, 4, and then 5. So you have here pentane. Then the methoxy is found on the second carbon. So that's why the name is 2-methoxy pentane. On the other hand, you have here 3-ethoxyhexane. So again, locate the longest carbon chain. And then after that, select whether you will start on the left or on the right. Since it is closer to the right, you have to start with the right. So this is 1, 2, 3, 4, 5, and 6. So you have here 3-ethoxy because you have al ethyl here, no? So it is 3-ethoxy. Ethoxy meaning ethane, 2 carbon, found on the third carbon. So that's why the name is 3-ethoxyhexane. So for the common name, it is easier than the UPAC system. Again, for the common name, the last word is ether. So like this. And then you just have to name the alkyl substituent. So this is methyl, one carbon. So that's why the term is methyl. Then space. This is ethyl. So that's why the name is methyl ethyl ether. On this side, you have here both are ethyl. Yan. So you have to name it as diethyl since there are two ethyl. So you will not call it as ethyl ethyl ether. But instead, you have to write here diethyl ether. Okay. So let us now proceed to the physical property of the ether. So you have here physical state, colorless compounds with characteristic relatively pleasant odors. And for the boiling point, they have lower boiling points than alcohols with an equal number of carbon atoms. So for example, um, alcohol, let's say butanol. So butanol has 4 carbon atoms. Then equivalent here in ether is diethyl ether. So they have lower boiling points than alcohol. Now, when it comes with the solubility, they have low molecular weight ethers such as dimethyl ether are quite soluble in water. So when we speak of soluble, that means that they can be dissolved in the water. And whenever you mix ether with water, such as this, you can no longer identify which one is ether because it already dissolved in water. Now, for the preparation of ether, one is dehydration of alcohol. So it takes place in the presence of acid catalysts. These are the catalysts which do not mix with the reactions, but they speed up. No, so we have here sulfuric acid and then phosphoric acid. Then another one is Williamson synthesis, wherein an alcohol is converted to its alkoxide by treatment with a reactive metal. That reactive metal is a sodium or potassium. Then displacement is carried out between the alkoxide and alkyl halide. So let us talk about epoxides. So it is a cyclic ether in which oxygen is one atom of a three-membered ring. Only the three carbon ring, no, are known as epoxides. Other may be called as cyclic ethers. Okay, so for the functional group of an epoxide, you have here uh, two carbon and then one oxygen. So that's why it is three-membered ring. No, not three carbon, but three-membered ring. So one place it represent a triangle as its structure. Okay, so you have here ethylene oxide. Okay, so then ethylene, because there are two carbon uh, present in the formula. And then you also have propylene oxide. So you have there ethyl and then methyl. So propylene, because there are three carbon atoms attached to the oxygen. So propylene oxide. So these are other cyclic ethers with their uh, common names and a UPAC name. You have here oxacyclopropane, oxirane, oxacyclopentane, oxolane, oxacyclohexane, oxane. Then the one at the bottom is furan or 1-oxa 2,4-cyclopentadiene, known as oxol. And then you have here 1,2-oxacycloheptatriene or 1,2-oxazepine. Though we will no longer be studying how they came with such names, no. The point is that you have to determine, no, or you have to look into the different cyclic ethers. Okay. Now, for the reactions of epoxide, so ethers are generally unreactive to aqueous acid. So when we speak of aqueous acid, these are acids found in water. So epoxides, however, react readily because of the angle strain in the three-membered ring. Reaction of an epoxide with aqueous acid gives a glycol. So just like this one, you have your ethylene oxide, uh, wherein uh, with water and then the acid. So it is converted to ethanediol or known as glycol. So it is now known as ethylene glycol. So same thing as with the second example at the bottom of the image. These are some of the uses of ethers. So they are used as fuel. So diethyl has a high octane number of 85 to 96 and is used as a starting fluid. So in combination with petroleum distillates for gasoline and diesel engines because of high volatility and low flash points. So they are mixed with the gasoline and diesel. Now, for laboratory uses, it is used as surgical anesthetic. Surgical anesthetic means if someone will undergo surgical operation, so ether can be used as anesthetic. Diethyl ether was formerly used in place of chloroform because it had a higher therapeutic index, a larger difference between the recommended dosage and toxic overdose. And diethyl ether depresses the myocardium and also increases tracheobronchial secretions. So yeah. All right, so that ends my discussion about ethers. So thank you and see you again on our next video.